So ladies and gentlemen, we're going to start the course in section 1.2, which is all about exponents. Exponential expressions is what we're going to call this section. But we want to begin with the definition. We want to define exactly what is an exponent. So let's say you got a real number, a. Let a be a real number. So you hear the word real number. I don't know if you remember from high school what a real number is. But a real number, it's this word right here. A real number is any number that can be represented as a decimal. For example, the number 5 is a real number because it can be represented by 5.0, right? A decimal. The number 1/3 is a real number because it can be represented as a decimal. 0.333333333 repeating, right? The number pi. Remember that number pi that has to deal with circles? Pi. That is a real number because it can be represented in some kind of decimal form. It's a decimal that never ends. It has no patterns, like 3.14, and it goes on, it goes on, it goes on, it goes on. It can be represented by decimals. So most of the numbers that you're familiar with are numbers that can be represented as decimals. They're called real numbers. All right, so let's say we got a real number called a, and let n be a positive integer. Be a positive integer. So what's this word mean? Positive integer. That's just the counting number that's positive. So it's like 1, 2, 3, 4, 5, or so. Positive integer. It's just a positive counting number. Okay, then we want to define what a to the n power means. What does a to the n power mean? Here we're defining an exponentiation, a to the n power. That is literally a times a times a bunch of times. The question is, how many factors of a do you have there? How many factors? You have n factors of a, right? N factors of a. So basically, the exponent, n, is telling you how many factors you're going to have in that long multiplication. So for example, if I were to write a to the 4th power down, that would be equal to the same thing as what? A times a times a times a. So that's 4 factors of a multiplied together. A times a times a times a. All right, so the next set of examples, I'm going to ask us to perform the exponentiation operation. I'll just say for short, perform the operation. Perform the operation. All right. So let's say we have number 2 here. So I have 5 to the 3rd power. So what does that mean exactly? Right, so that means I'm going to do what? 5 times 5 times 5, right? We got 3 copies of 5, and they're multiplied together. So what I can do, I can multiply the first 2 together. What's 5 times 5? That's 25. And let's not forget that we have an additional 5 there on the end we haven't used up. Now we have to do 25 times 5. 25 times 5 is 125. All right, so that's 5 to the 3rd power. 5 multiplied together. 3 copies there. All right, number 3, an example. Let's say we were to have negative 2 in parentheses to the 5th power. So what does that mean? That means you have a bunch of negative 2's multiplied. Now, rather than doing the dot, I'm just going to put parentheses around each one. I like to do that on negative numbers in parentheses. So a negative number exponentiated, I'm going to keep them in parentheses. So negative 2, negative 2, negative 2, negative 2, negative 2. So I have 5 copies of negative 2 multiplied together. So the first two negative 2's, that's going to be what? Negative 2 times negative 2 is going to be positive 4. Remember, a negative times a negative is a positive. And then the second two pairs of negative 2. Negative 2 times negative 2 is going to be a positive 4 once again. So we used up the first two negative 2's, the third and the fourth negative 2's, and don't forget you got the fifth negative 2 there on the end, so we'll just leave that. So we got, okay, let's do 4 times 4. 4 times 4 is what? 16. So I'm going to write 16 down here. Let's not forget that negative 2 we have not yet used. 16 times negative 2 is... Well, remember what a negative times a positive, or a positive times a negative is. A positive times a negative is a negative. So it's going to be a negative 32. Okay, so negative 2 to the fifth power is negative 32. All right, let's do another 4. Number 4 example. Let's say I got negative 3 in parentheses to the second power. This means we're going to exponentiate negative 3 twice. So I'm going to take negative 3 times negative 3. Now, negative 3 times negative 3 is going to be positive 9, right? A negative times a negative is a positive. So we expect the answer to be positive because you got negative times negative. All right, that's interesting. Look, we took a negative number, negative 3, to an even power, and it came out positive, right? It's always going to come out positive if you have a even power above anything in parentheses. Let me say that one more time. If I ever have anything in parentheses, doesn't matter if it's a positive or a negative in parentheses, and then I got an even power above it, it's always going to turn out positive, always. All right, here we go. Number 5. This time I'm going to have negative 3 squared. Now this is very different than negative 3 to the second power. This is negative 3 to the second power, right? Negative 3 to the second power, which is different than negative 3 to the second power. So what does this mean exactly? Different than number 4. So what this means is I'm going to take the negative and copy it down out front. So I'm going to copy down a negative out front. That's my green negative right there. And then what I'm going to do, I'm going to take 3 squared. I'm just going to write 3 squared. What does that mean? 3 times 3. This is a completely different situation than number 4. All this means is you write a negative and then 3 times 3. 3 times 3. So this is equal to negative 9, right? 3 times 3 is 9. So be aware that this is a very different situation than number 4 because the negative is not in parentheses, right? The negative is not in parentheses with the 3. The negative is separate from the exponentiation of 3 squared. All right, let's see. Can I scroll this thing? Awesome. The answer is yes, I can scroll. Let me see if I can do a number 6 example. Be fantastic. All right, I'm going to do negative 4 to the third power. Negative 4 to the third power. That's the way you say that. So I'm exponentiating negative 4 3 times. So I'm going to do negative 4 times negative 4 times negative 4. Negative 4 times negative 4 times negative 4. So when I multiply the first pair of negative 4's, I'm going to get a positive, right? A negative times a negative is a positive. Positive 16. And let's not forget that additional negative 4. So then I got to do 16 times negative 4, right? 16 times negative 4. Remember, positive times a negative is a negative. 16 times negative 4 will be negative 64. All right. Yeah. So notice that when we have a negative in parentheses to an odd power, we're going to have an odd outcome. Pretty neat, huh? Pretty neat. That'll always be the case. If you have a negative in parentheses to an odd power, you're always going to have a negative outcome. All right, number 7. How about negative 4 to the third power. Negative 4 to the third power is different than negative 4 to the third power. What does this mean? What does this mean? Well, this means this green negative here you're going to keep in front. And then you're going to do what? 4 to the third power. What's that mean? 4 times 4 times 4, right? Multiplying. So essentially what you do, keep your negative out front, and then you start off doing, bless you, 4 times 4, which is 16. See if I can squeeze that in there. Okay, here we go. 4 times 4 is 16. And don't forget that additional 4 here on the end. So I'm going to keep that negative out front. Then we're going to do what? 16 times 4. What's 16 times 4? 16 times 4 is 64. So you get negative 64. Hey, look at that. We got the same thing as in number 6. Number 7 turned out to be the same as number 6. Yeah. So even though the negative in number 7 was not in parentheses, we ended up getting the same exact result as in number 6 when the negative was in parentheses. That'll always be the case when you have an odd power. They'll turn out to be the same. So in principle, by definition, negative 6 and number 7 are not the same by definition, but in actuality, when you do the computations, they turn out to be the same thing. So let's write an important set of facts for this bit of discovery here. Bit of discovery. So 2 facts we've encountered. So let's let A be a positive real number. So A is a positive number that can be written as a decimal. A be a positive real number. Number 1, if A, not A, if N, can I say the word N? Yes, if N is even, so we're talking about the exponent here, then it turns out that negative A to the n power is the same thing as A to the n power. So again, if your exponent is even, then the exponent basically kills off this negative here in the parentheses. Yeah. So negative exponents will kill, I'm sorry, not negative exponents, even exponents. Even exponents, even powers will kill off negatives in parentheses. That's an important fact. Here's another situation. What happens when you have an odd power? If n is odd, then what happens when you have negative a to the n power? What happens? Well, the odd power, n, does not kill off the negative. It allows you to basically extract the negative. So you can pull the negative out and just say a to the n power. Yeah, so negative a to the n power is the same as negative a to the n power. Anytime you have an odd power, so you have to remember the difference for the even case and the odd case. So in the even case, the negative gets killed off in parentheses, and with the odd case, you can pull the negative out of the parentheses. That's called extracting the negative and bringing it out front. All right, so I think we'll stop there, and we'll start up another video.